Yes, I do. All right. So we are starting chapter 6, which involves exponents. So all week this week, we're going to talk about exponents and what their rules are. Notice how we have a quiz Tuesday. Okay.
Isn't tomorrow?
Okay. So we'll get to those 3 problems that you just did, but first let's go over some vocabulary. Okay. So we are going to work with monomials. So what number does mono associate with? 1. So a monomial is one number, or it is one variable, or it is one product of a number and variable. It's an and. Okay, so examples of a monomial: a number, a variable, or a product. So like 4x, or it could be -3 x squared y cubed, or it could be 17 x squared y cubed z. Those are all examples of monomials. Basically, it's one term. Okay. Okay. Now, I heard somebody say this phrase. Okay. If we have monomials that have the same variables and exponents, then we consider these to be like terms. And I did hear one group talk about like terms. Now, I am going to take a moment while you write that down. This is not the first time I've asked you to do problems on the whiteboards. I went over what my expectations are, and I had many groups not follow it. I said, work together with your group. That doesn't mean one person does all of them. It also doesn't mean I do this one, you do this one, you do that one. No. You work together on problem 1. You work together on problem 2. You work together on problem 3. That was very disappointing. What? Okay. So, for number 3. I see some -9 a cubed BC. Noah, how did your group get that? Okay, so did you notice that we have a cubed BC, a cubed BC? Those are like terms. So Noah said, hey, all we had to do was add -15 plus 6 and then keep the a cubed BC, right?
Right.
Okay. If you didn't write that down, that would be a good one to write down.
No, that's
So I didn't say it was only one row. Why do you have 2 expo markers in your hand? Okay, while we're at this timeout, could you make sure that the blue, teal, green, and red tables have 4 expo markers, and that the yellow and purple tables have 6?
Our group has 4.
Oh, we have an extra one? All right, now let's look at number 9. Let's look at number 9. Up here, the aces. Okay, Brooks, 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 Brooks. Okay, the aces group has 7y plus 6z. Aces, Henry, how'd you do that? Could you be more specific?
The 3y and the 4y. It's 7y.
Okay.
The 9z minus 3 is 6.
So 7y plus 6z. Does that sound okay? Did you like his explanation? I liked the explanation. Okay, good. Now, number 11 was a little weird. Okay, what I see is that I had people keep separate the w and the w squared. Is that what I'm seeing?
Yeah.
Having a hard time? Like, you guys can't write this big. Whew. So, let's see. Harry, explain to me what are like terms in this one.
The 9w and the 31w.
Okay, those are like terms. And then, so you're saying these two are like terms? Okay, so you're doing great. Okay, what I highlighted in blue are like terms because it's just w to the first power. But what I have highlighted in pink are like terms because it's w squared. Okay, so we can combine 13 plus 4 to get 17w squared. And then we can combine 9w minus 31w to get negative 22w. What? Okay, so since these have different exponents, they are not like terms, so we have to keep them separate. Okay, and since this is a w squared and this is a w squared, it stays as a w squared. It's like when I have 2 apples plus 2 oranges, excuse me. Well, 2 apples plus 2 oranges, I can't add them together, right? But 2 apples plus 2 apples, they're still apples. So they are still apples, 4 apples. Okay. Do I make fun of you when you make a mistake? Okay. I want you to, with your elbow partner, do number 4, number 10, and number 12. I'll give you 60 seconds.
How do you do number 4?
It's gonna be 37x squared y.
Number 3, it's x cubed y minus x cubed y. That would just mean it's 2b.
Isn't that like 2b plus 8a?
Yeah.
2b plus 8a minus 2b. Well,
Writing out on this.
yeah.
So let's say when you're
I'm gonna take one of those. I'm gonna find like a traffic cone. And then
So like
to
meaning add the coefficients.
Put a gyro rubber band on it.
Whenever,
And one of those
like,
paper things. Noah. Do you have a PVC pipe or a cone? I have a what? I look at PVC pipe or a cone.
Okay, go ahead and make 5. Make 5. Okay, I had some people asking some questions during this time. Okay. If we had like an a to the 5th minus an a squared, these are not like terms because the exponents on the a's are different. Okay, but if we have like a 5ab squared minus a 2ab squared, since these right here are the exact same, they stay the exact same, and you just add or subtract the coefficients. Does that make sense? Okay, so Ellery, what did you get for number 4? Okay, notice how we have like terms. This guy just has a coefficient of -1. Okay, so we keep the like terms and we add, or in this case, subtract our variable, our coefficients. I'm not saying the right word at all, our coefficients. Okay, number 10. Allison, what'd you get for number 10? Okay. Brooks, how did she get 2b plus 8a?
She simplified by doing 12b minus 10b.
Okay, and then 8a is not a like term, so it's just kind of a loner. Okay, now number 12, I really like number 12. Brooks, why do you not? Okay, so are all 3 of those like terms?
No.
Okay, notice how this one is m squared n. Is this m squared n? No. Is this m squared n?
Yeah.
Okay, so those 2 are like terms, which means we can combine them to be 9m squared n. Right? Because this is a -1. Okay, but then this guy is mn squared. It is not a like term, so we cannot combine it. That's where we stop. Okay. All right, turn it to page 2. Okay, so I'm going to tell you that x to the 4th times x squared is x to the 8th. And I'm going to tell you that y cubed times, nope, that's not right. Hold on. Sorry. X to the 4th times x squared is x to the 6th. Y cubed times y is y to the 4th. And I'm going to tell you that z squared times z to the 5th is z to the 7th.
So it's just like addition, but. No, it's just addition.
Okay, what's the rule? What did somebody tell me what Kyron said, but at a more. You add the exponents when you multiply. I really like how you said that. So right here where it says product rule, if we are multiplying, and this is important, as long as our base is the same, then we are going to take our exponents and we are going to add them. Okay, so if we are, what? Ooh, we will talk about that soon.
So is it gonna be, let's see. Can they do both?
What?
Because a squared plus b squared equals c squared.
That doesn't mean A plus B equals C.
It's not squared.
The other one, if you were adding, you couldn't add because these two are the same.
So they have to stay this. The letters stay the same, and then you can add the coefficients.
So when you're multiplying,
The exponents, yes. All right, so let's go to these three right here. If we are multiplying and we have the same base, the base stays the same. But then what does our exponent become in this one? 5. What is the exponent on this guy right here? So a to the 9th times a to the 1st is what, Drew? You said it. A to the 9th times a to the 1st would be a to the, sorry, Kaylee, I thought it was Drew's voice. Okay, you and your elbow partner whisper to each other what the exponent is going to be for W on number 19.
Definitely no.
Okay, Connor, what's the exponent? 11. Okay, now you can do this all day, couldn't you? Okay, so what happens when we throw in some coefficients? Okay. If we are multiplying, do you know how to multiply two numbers together?
Yeah.
Okay, so we're gonna multiply the numbers together, and then we're gonna do our rule with our exponents, okay? So like in number 20, don't overthink this. Do we know how to take 4 times 3? What is it? 12. But then we have x squared times x to the 5th, which would give us x to the 7. Okay, somebody's freaking out over here about number 24. Let's go to 24. Okay. So here's our multiplication right here. Let's just do one thing at a time, Brooks. Are you ready? What is -7 times -4? I'm gonna let you try that again. -7 times -4. Okay. Okay. If we have p to the 9th. Okay. If we take p to the 9th times p squared, we would get p to the p to the what? Haven't I told you you can't do that because you're gonna kill my shin?
You never told me that. You must be thinking of some wrong person.
Whatever, Bruce, thanks to you. Okay, how about q to the 3rd times q to the 6th? We're gonna add our exponents, okay? Then, Kari, what about r times r to the 4th? You guys are making me so happy. Okay, so this is what you're gonna do. You and your elbow partner are gonna do number 25, number 26, and number 30. Ready, set, go. What? Huh? That's a 5.
How do you do this?
It has an exponent of 1. If there's not an exponent, it's an exponent of 1.
Thirty. I got negative 31.
So that's like subtracting a negative.
It's not why. It starts. No, negative 30.
You're taking negative 15 and
It's 6. I'm gonna fail this one. I'm sorry.
Okay, you're doing those 3 problems.
I know. Miss Holman. Miss Holman's chair is broken.
Yeah, clocks are usually stop.
Stop leaning on
I don't think anybody ever took that.
Oh, you're like, how going on? Okay, so it sure sounds like we're done. Ian, what did you get for 25?
I got negative 24x.
Of what?
What?
I would. Interesting. Okay. Here's your PSA, right? So I can read it. Public service announcement. Ah, so 8 times negative 3 is negative 24. X to the 4th times x to the 4th gives us x to the 8th. Y squared times y to the 9th is y to the 11th. Amazing. Number 26. Reese, what'd you get for that one? Good. This is a y to the 1st, so we got to add all 3 of those together. All right. DJ, what'd you get for 30? So this is a d to the 1st power, d to the 6th. Okay. Now, here's where we really get to have some fun. Look at number 35. What operation do we need to do first? Multiplication. So if we multiply this guy right here, what is 2 times 4? What is x to the 5th times x? X to the 6th. What's y squared times y cubed?
Y5.
Okay. Plus, now we have to multiply this guy. I don't have a coefficient on the first one. What is it? So what's 1 times 3? What is x to the 4th times x squared? What's y to the 4th times y?
Y5.
Y to the 5th. You're not the only one saying it like that. Y to the 5th. What do you guys notice?
I prefer Wi-Fi. It's easy.
What do we have?
An equation.
That is what I was looking for. We have like terms. 11 x to the 6th, y to the 5th. Isn't that incredible?
Oh, yeah.
Incredible. Yes.
When there's like no number in front of
Yep. Say, do you want to know your homework is? It's page 3. All of it.